Okay, so in this video clip, I'm going to take a look again at some binomial American option pricing. We will include a dividend yield in the parameter inputs. The code originally was taken here from this GitHub. We'll take a look at that in a moment. The only change or tweak we introduce is to input a dividend yield. Dividend yield can be important, especially when we're looking at American options, because if the dividend is zero, then the American call is equal to the European call. So it's worthwhile throwing in a dividend, but that's a fairly minor change here overall. The code, I would have to say, is really parsimonious, which is great. And the only library that we import is NumPy, and really we can demonstrate the power of NumPy here and demonstrate in instances where Python, which is generally considered to be slow, can actually be set up to be really fast, right? Incredibly fast, in fact. So let's take a look at the GitHub first of all. I think it's probably good that we just copy that and just go in and have a look here at the GitHub. It generally speaking, it's a really good GitHub, and maybe take a look at Nicola Cantarutti, right? And Nicola's done really incredible work here on this GitHub. For me, I found it really useful, and I strongly recommend that people take note. But I'm just this instance, I'm just going to take a look at the American option, and the code here for the binomial I borrowed from this segment here, right? So go back, take a look. Now you might note there's no dividend yield here, but it's a relatively trivial exercise to put in a dividend. Okay, so what do we have? Well, we have our usual parameter inputs. I've taken these from Brody to Temple 1997. And just to confirm that when we do output some numbers here for the American option, that are consistent with the literature and are broadly in line with the literature, which they are. So we load in the parameter inputs. And again, the only library that we'll use here is the NumPy, right? So there's nothing extra. We're using Google Colab, which is a Python notebook. I'm loading in some basic parameter inputs, the NumPy library. Then I'm going to estimate the binomial American option pricing tree at 5,000 steps. And you can see here the output is incredibly fast. We can raise that up to 15,000. Take another look here and run. Again, when we come down, it's almost instantaneous. That's incredible. And what it points to is the incredible power of NumPy. Now, why might it be powerful? Well, it was developed originally as a means by which to speed up Python. Python was a little bit slower, and this library is a Python programming language adding support for large multi-dimensional arrays and matrices. So this is what we have. We have multi-dimensional arrays in the binomial tree, and along with a large collection of high-level mathematical functions to operate these arrays. The ancestor of NumPy, numeric, was originally created by Jim Hugonin with contributions from several other developers. Okay, so there's a little bit of history there, probably worth exploring. But why is it so fast? Well, the core of functionality of NumPy is the array for n-dimensional array data structures. These arrays are strided, views on memory. In contrast to Python's built-in data structure, these arrays are homogeneously typed. All elements of the single array must be of the same type. And so importantly, such arrays can also be views into memory buffers allocated by C and C++, Cython, Fortran extensions to CPython interpreter. So basically, we're able to leverage with NumPy much of the of our activity can be set up to get C-type performance, right? So although Python is generally considered to be quite sluggish, really good in terms of general computing and for data science, but there can be speed issues. A lot of those issues in where we're using multi-dimensional arrays can be resolved using NumPy. Again, to give a sense of, again, I can, when I, the result we have here is correct. I've checked that, and I've checked a few results here. They're consistent with the literature. And also